Hello everyone. Today we are going to discuss the concept of server failure handling and catching in NFS. The contents which we are going to discuss are handling the server failure with idempotent operations along with client-side catching. For discussing the server failure handling, we should know about the various NFS protocol procedures. So first we will take the brief overview of various NFS protocol procedures. When we have to consider the files, we must require the various attributes of the file. So for that, we will use the get attribute procedure. When we have to set the attributes for a particular file, we have to use the set attribute procedure. When we have to look up for a file, we will use the lookup protocol procedure. When we have to perform the various operations like read, write, creation of file, then we have to consider the according NFS procedures. Also, for removal of the file directory, we have to consider the remove and RMDI procedures. For making the directory, we'll use the make directory procedure, and for reading the directory, we have to use the read directory procedures. So these are all the procedures which you will require while considering the NFS protocols. Now we will start with the discussion of handling the server failures considering the idempotent operations. So at start we must know what are the various idempotent operations. So when if we consider a client want to perform any particular operations, and if that operation is not done in one go, then it will simply retry that particular request or operation, and this particular activity is considered as the idempotent activity. So the ability of the client to retry any request is considered as the idempotence. If we are considering any particular operation which is occurring multiple number of times, it will become equivalent to the effect of considering that operation occurring only once. We are considering the instance here. Suppose any particular value you want to store to a particular memory location, and you are doing that particular storing operation thrice. Now, considering the idempotent operation, we will consider it is same as doing it once. Now, as we have seen earlier, discussed earlier, storing the value n number of times to the memory location is the idempotent operation. When we consider another instance, suppose we are incrementing a counter thrice. Now, suppose the counter is at start 1, then it has become 2, 3, 4 likewise. Means it is giving you the different values at each time. So it will be not a idempotent operation because it is changing the values. The previous instance which we have discussed considering the storing of a particular value to a particular location multiple times, it will result in the same. So it is a idempotent operation. So just reading is naturally again a idempotent operation. Suppose particular file we are considering for the reading, and we are reading it n number of times, the result will be the same. So it can be the idempotent operation. We can here conclude that reading and storing to a same location can be the idempotent operation, wherein updating any value, as we have discussed for the incrementation of the count, updation of the value will not be a idempotent operation. Here if we are considering the idempotent operation, we have to consider handling the server failures for the various idempotent operation. You can see here we are considering the different cases, and here in each case we are considering the data lost from the server side. In the case 1, client is sending the request for a data to the server, but server failed to receive that particular request. No message is obtained at the server side. So we can conclude that the request has lost. In the case 2, again client is sending the request for any information, but unfortunately the server is down. Again it is having the loss of information and the request is not processed correctly. In the third case, client is sending the request to the server. Server has successfully received the request. He has handled the request successfully at the server side, but when the server is sending the reply as the acknowledgement that the operation is performed correctly and sending the result to the client, at that time the failure has occurred. So you can see here there are various cases: request lost, server down, or reply lost, but the operation is unsuccessful. So all this server failure considering the idempotent operation must be handled correctly and efficiently so that the performance will increase and the failures will be less. Now, for improving the performance, we have to consider the client side caching. How the client side caching is done at NFS, we will discuss that now. So the NFS file client side caching will cache the file data along with the metadata, and it will consider it from server side. From server side, it will read the data and it will store it in the client's memory. After considering this operation, once at start, the access will be expensive, but subsequent accesses are serviced quite quickly out of client memory. And the cache also serves as a temporary buffer for writes. Means if you are considering the write operations, the cache will consider that too. Now, if we consider the write operation, suppose we are assuming client application first writes to a file. Then at that time, the client buffers the information in client memory before writing the data out to the server. Adding cache into any sort of system with multiple client caches introduces a big and interesting challenge, which is nothing but the cache consistency problem. So we can conclude that if we are considering a number of client caches and they are performing different operations, reading, writing, updating, likewise, if they are handled parallelly, it will be the challenge, which is nothing but the cache consistency problem. So for discussing the concept of cache consistency along with the server failure handling with idempotent operation, I have referred this as the references. Thank you all. I will end here.